We're going to look at an example that is looking or given a graph of f. Okay, so notice what's going on here. This is our ultimate goal, is to get to this level. We are given g of x, even though we're given f of x over here. So immediately what we need to understand is that if I look at this integral, I have t and t. So in terms of t and in respect to t, but then I also have in terms of x here and here. So already this is screaming at me second fundamental theorem. So let's take the derivative of the left side, and that's easy. It's just g prime of x. And when I take the derivative of the right, just like we started this video, we will put f of something minus f of something. Remember, it's the original integrand. Everywhere where there was a t, I put parentheses. And that's that f of b minus f of a. And now I'm going to plug in the top limit of integration and multiply by its derivative. Plug in the bottom limit of integration, multiply by the derivative of 0. This zeroes out, and I'm left with f of x. So g prime is f of x. Okay? So now, and this right here, we're going to go ahead and mention it right now, is Peir's second fundamental theorem. So when we're asked to find the position on g at 0, it's just using this function here where we're going to plug in 0 where we see an x. Not a t, but an x. Well, 0 to 0 has no displacement. So you know that that's going to equal 0 right off the bat. So part A, g of 0 is equal to 0. And I'm just going to write it out just for this first one. And we're plugging in this 0 right here. And it's going to have 0 because you can't have displacement if you're not moving x-wise. Okay, so now let's look at the next one. We're looking at g of 3. So g of 3 is saying the integral from 0 all the way to 3 on the f graph. Okay, so the f right here, let me highlight it in green, is talking about this function here that you see in the picture. And we want to integrate, aka find the area underneath the curve, from 0 all the way to 3. So we have from 0 to 2, and then we'll go from 2 to 3. Whatever this displacement is, that's going to be my y value on g. Okay, g is a function that we never see. So let's find this area here. Well, I know that this is a quarter, if you will, of a circle. So the area of a circle is pi r squared. We have a radius which looks like it is 2. So 4 pi is going to be divided by 4 because we want a fourth of it, and that's going to be pi. Okay, so I'll divide this up here also by 4, just so that you know that this is a quarter of a circle. So those cancel to a form of 1. Pi is my y value. So if I was looking at g, so far I have 0, 0, and this is g of x, a graph that we never see. I have 3 pi. And now let's find these other ones. We have g of negative 2, and we have g of 5. Okay, let's look at this negative 2 piece. So I'm saying from 0 on f, let me go ahead and write this one out, from 0 on f, whoops, and I'm going to go ahead and plug in these x values of negative 2. Remember, that's where the x is at here, and 5. Now, this right here should kind of be screaming at you. You are so used to doing from left to right or lower limit to upper limit that this doesn't make sense right now. And one of our rules, our laws of integration, is that we can flip these. We can flip the lower number to go on the bottom and the higher number to go up top. But when we do that, we have to account for it with a negative, okay? And then the rest of it is still the same, f of t dt. So now we're reading it just like a book. From negative 2 to 0, in other words, from here to here, we're going to find the area underneath this, and then whatever it is, then we're going to multiply that by a negative, okay? So from negative 2 to 0, it is similar to 1 to 2, or sorry, 0 to 2. So it's that quarter, which is going to be a pi, because it's above the x-axis we're going to read this as a positive. Let me highlight that as I go. This that I'm highlighting in orange right now, I'm reading left to right to find this area, okay? So everything above the x-axis is positive. Everything below the x-axis is negative if you're reading left to right. And that's why I did this change of bounds, and I flipped them. Because then at the end, whatever I get, I can just multiply it by negative, and I'm not making those infamous negative mistakes in calculus. So that's a negative pi. So if I wanted to see that as a point like I saw these, I have -2 and negative pi is that point. All right, let's look at g of 5. So g of 5 wants us to go from 0 all the way to 5, okay? So we're going to be doing, and I'm just now realizing, and some of you are probably like, whoa, what is he doing? That this isn't simply pi over here, okay? So let's back up just a little bit. G of 3, this part was pi, but I forgot to work with this part here. So this is the area of 1/2 times base times height, which is 1 and 1. So this is just -1/2. -1/2 is the area of this little mini triangle right here. So pi minus 1/2 is going to be that value. And sorry for that mistake, but we did catch it. Okay. So now let's go all the way to 5. And I'm going to still go from 0. Well, I know that I've calculated to 3, which is a positive pi and a negative pi over 2. So if I'm going to go all the way to 5, I'm going to basically tack on to that this area and this area. Well, this area down here is a -1/2 because I'm reading left to right and it's below the x-axis. This is a positive 1/2. So when I add these are just going to cancel out. So g of 5 is also the same as g of 3, okay? So we have 5 pi minus 1/2 is going to be the y value. And again, this is if you were looking at a g function, if it was there. Those are the point interpretations. Okay, so all that just for part A, but I wanted to break it down and make sure that I went through it all. Let's go now and pick up the pace just a little bit to go to part B. It says, find all the x values on the open interval from -2 all the way to 5, at which g has a relative maximum. Okay, g has a relative maximum. Now, underlining that alone, g has a relative maximum tells me that g prime of x is going to change from positive to negative. Now, I don't have a g prime of x, okay? So if I'm looking at, let me kind of clear some stuff up so it's not too overwhelming. If I'm looking for when g prime of x is changing from positive to negative, I don't have a g prime. But I know per second fundamental theorem that that's the same, g prime is the same as f of x. So it's the same as if I were to say f of x is changing from positive to negative. So I do have an f of x graph, okay? F of t and f of x, it's an f graph, okay? And if I want to know when it's positive to negative, I want to know when does it change from, when does it cross the x-axis from a positive over to a negative. So this is going to occur here at 2, because that's when I go from above the x value or the x-axis to below the x-axis. Okay, so y value interpretation, that's changing from a positive y to a negative y value. Okay, so we're going to say for part B, a relative max occurs at x is equal to 2 because, and you can do either one, g prime of x changes from positive to negative. I'm just going to save a little bit of time by just copying this over. Maybe. Yep. So let me kind of move it down. And you could write g prime of x, or some of you might elect, because you know g prime is equal to f of x per second fundamental theorem. Some of you might just go ahead and have written all of this, but with an f of x. So you don't have to write both, guys, but I would say to make sure that you have this written in your work to include that, the AP reader does know that you know what f of x and g prime of x and how they're related to one another. Okay, so all we wanted to know were the x values, and we're good to go because that's the only place where it does occur. Okay, and this is going to be a relative maximum. You're going to say per first derivative test. Because remember, first derivative test aims to find relative maximums and relative minimums. Okay, so now let's go to part C. Same problem, just copied over, just needed more space. Part C says, find the absolute max, or sorry, the absolute min of G. So that means for G, if I have, let me go ahead and write part C down here. For G, if I had just one critical point when G prime of x is equal to 0, just one, okay, then I could use first derivative test, okay? But if I looked at G prime of 0, G prime of x is equal to 0, which is the same as f of x is equal to 0. Again, that's per this second fundamental theorem that I'm going to go ahead and bring over to this next slide. Okay, let's put that right there. If I only had one, and let's say that I had just one critical point when that occurred, okay, just one. And let's say it occurred at a C value. And this interval changed from negative to positive here. And this was the only place where this happened, okay? You could write G prime or f of x. Then you would have the absolute minimum also occurring here, okay? Because that's the only critical point that it's changing at. But if you're looking at from negative 2 to 5, it happens to cross the x-axis or equal 0 on f 2 times. So you're not going to be able to necessarily use this. That's why it's safer to go ahead and just use candidates test, okay? I tell my students, when you see absolute minimum or absolute maximum, chances are you just want to go straight to candidates test. But if you do want to test how many critical points it has to save a little bit of time, you're more than welcome to do that as well. If you struggled with understanding what I just said, just go to the candidates test. It will not fail you. So per candidates test, we know we're going to have a chart of x, and in this case, we're looking at g of x. And we know we already have two candidates, negative 2 and 5. Now, I have to find all of the critical points that occur between negative 2 and 5. On G, that means when does G prime of x equal 0? We know G prime is the same as f of x. And what we just found was at 2 and at 4 are the critical points. So now we have 4 candidates. So I wonder what G of negative 2 is. Well, G of negative 2, we solved actually back here, in part A. G of negative 2 gave me a negative pi, okay? So we'll put negative pi here. G of 2, right, let's see, did we find G of 2? No, we did not find G of 2. So we'll find that here in just a bit. Actually, did we find G of 2 yet? I believe we did. I thought we did. No, we found G of negative 2, but not of positive 2. Okay, so we can find that real quick. G of 2 is just plugging in this x value right here. And going from 0 to 2, you know that it's going to be this quarter circle here, which is a positive pi. G of 4, if we kept going, we're going to have 1/2 times this base. Let me go ahead and do it like this. 1/2 times base, which is 2, times height, which is 1. So this is just 1, but because it's below the x-axis, is interpreted as a negative 1. So that's a negative 1. And then G of 5, we did have G of 5. It was this one right here, pi minus 1/2. So if I want to know the absolute minimum, This is like 3.14 minus 0.5, okay? So this is like, if I'm subtracting this, this is a little bit like two and some change, if you will, like 2.6-ish. 2.6, 2.56, somewhere around there, okay? But it's still a positive. Here we have a -1, we have a negative pi. So this one's way, way more negative. So we're going to say the absolute minimum value of g equals negative pi. And then it says, and the value of x at which occurs. So we're going to say at x is equal to this -2. Absolute min is the y value. At is the x value. So now let's go to part D. Part D says write an equation of the tangent line for g. So we're going to say y minus something equals the slope times x minus 3, because that's our at value. Okay, so let me go ahead and do that. So now I need g prime at 3 to go here. Okay, g prime is f of x. So that means if I'm looking for g prime of 3, it's the same as looking for f of 3. And we know from the graph of f up here that at 3, my y value is a -1. So remember, g prime is equal to f of x. So therefore, at f of 3, that y value is going to be the same as g prime of 3. So that y value is a -1. And now we need to find g of 3. Okay, and g of 3 from before, we found that in part A, g of 3 was pi minus 1/2. Okay, so pi minus 1/2 is going to go here. Be very careful because of the fact that I have two terms here. I need parentheses so I don't make yet another negative calculus mistake. So there's my answer, though. You don't have to simplify this out. This is in the equation of a tangent line form. Okay, if you wanted to, have at it, but be careful. Simplify at your own risk. You don't want to make mistakes with that. Let's move on to our last two parts, and then we're done with second fundamental theorem and these extrema on intervals. Find the x-coordinate of each point of inflection on G from -2 all the way to 5. Okay, so we know points of inflection. Per definition of point of inflection, we're going to say occurs at x is equal to, and we need to find when does the second derivative change signs. Remember, we're talking about g. So when does the second derivative change signs? Or, since we know, very, very important, since we know off the very beginning that g prime is f of x, well then g double prime is the same as f prime. Okay, so if g double prime is changing signs, g double prime is changing signs, that's the same as saying f prime is changing signs. So f prime changes, check this out, watch what I'm showing you, f prime changes from positive, let me move this over to the left because I know I'm going to run out of room. From positive to negative, or changing signs means that I could change from negative to positive. Okay, so let me go ahead and put that down here. Now, careful, watch what I'm going to show you. G double prime changes signs means f prime changes signs, and f prime changes signs is shown here. And the reason why I showed you that is f prime changing from positive to negative is the same as f changing from increasing to decreasing. Vice versa. This bottom one would be from, oops, I see what I did. I need to change this to a negative and a positive. The bottom one would say f of x changes from, those are just ditto marks, decreasing to increasing. So basically just find a max, a relative max or a relative min. So when f is changing from increasing to decreasing, we know that occurs there And if it changes from decreasing to increasing, we know it occurs here. So our point of inflections are going to occur at x is equal to 0. That's for this first one. And x is equal to 3. And you're going to say because g double prime changes signs, or what we ultimately went to, f of x changes from not positive or negative, it changes from increasing to decreasing or vice versa, or decreasing to increasing. If you understand that, guys, you understand second fundamental theorem and also extrema on intervals. Okay, you're definitely sound if you understood that part of f prime is positive makes f increase and vice versa. All those different pieces you're definitely sound on. Okay, all right, so now let's go to find the range of g. Okay, so the range of g is going to come from -2 all the way to 5. If we were to list out all those y values per se, we have them way back here, -2, 2, 4, and 5. Okay? So the range is going to be what is the lowest all the way to the highest value? The lowest value looks like it is -pi, and the highest value looks like it's occurring at 2. Now, if I went back here where it was increasing to decreasing, we saw that we were going to have this relative max occur at 2. Okay? And the minimum, were we asked about the minimum? No. Yeah, we were in part C. And the relative minimum or the absolute minimum was the one that occurred at this -pi. Okay, so the range, if you will, of what it's asking, it's going to be f, the range of g exists on -pi to pi, or you could just say goes from -pi to pi. So when we did mean, median, mode, and range, the range for mean, median, mode, and range was the top minus the bottom. So it's like this minus the bottom, which would be 2 pi. I don't believe it's asking for this type of range. I don't believe it's asking because that's mean, median, mode, and range. I believe that it's asking for the actual quantitative y values of that, which would exist as a defined range, would be from -pi to pi.